Hello and welcome. In this video, we will learn what the volume mesh quality is and how to improve it in the Ansys Fluent Meshing watertight geometry workflow. The volume mesh has a significant influence on the accuracy and stability of a simulation. To ensure an accurate modeling of the fluid flow physics and all the necessary flow features, it is not only critical to ensure appropriate mesh resolution, but also the creation of high quality mesh. Mesh quality refers to the quality of the cell that make up the volume mesh. The evaluation of quality can be done using various measures such as skewness, aspect ratio, warp, etc., which are defined primarily based on the cell shape. The default measure reported in the watertight geometry workflow is the orthogonal quality or orthogonality. Once the volume mesh is created, the minimum mesh quality measure over the entire volume mesh is printed in the console window. Depending on the reported value, the volume mesh can be either finalized and transferred to the Fluent for performing the simulation, or an improve the mesh quality can be performed to improve the quality of the volume mesh before switching to the solution mode. Let us now look at how the orthogonal quality measure is defined. It is the measure of the alignment between the vectors normal to the cell faces and the vectors connecting cell centroid with face centroids, which is determined with the help of this equation, and also between the vectors normal to cell faces and the vectors connecting cell centroids of the adjacent cells, which is determined with the help of this equation. The minimum value that results from these two equations for all the faces is the orthogonal quality for the cell. It ranges from 0, which is poor, to 1, which is perfect. A mesh should have minimum orthogonal quality always greater than 0.01, but it is highly recommended to maintain it above 0.1 whenever possible. Let us now understand how to check and improve the mesh quality in the Ansys Fluent Meshing watertight workflow with the help of a demo problem. Launch Ansys Fluent in Meshing mode. Go to File, Read and select Mesh and then pick the provided mesh file. Once Fluent finishes reading the file, you will notice that the watertight geometry workflow has been automatically set up and all the tasks till the Add Boundary Layers task have already been successfully completed. The model we have here is that of a generic 2-element rear wing found on a Formula Series type race car enclosed within a virtual wind tunnel. Except for the inlet and the outlet, all the other sides of the wind tunnel and the wing geometry are considered as walls. The model consists of only the fluid domain with the wing considered as a void. Now let's generate the volume mesh with the default settings for this demo. Once the mesh is generated, Fluent displays the mesh quality value in the console window as shown here. Alternatively, mesh quality can also be checked by clicking on the Mesh tab at the top and then on Check Quality. This will display the minimum orthogonal quality value along with the maximum aspect ratio in the console window as shown here. If the user is interested in computing and displaying the other mesh quality measures, navigate to Cell Limits under the Report tab and select Quality Measure from the pop-up box. In the Quality Measure pop-up window, select the appropriate quality measure and hit Apply, and after selecting the required cell zone in which the quality measure needs to be computed, hit Compute. This calculates and displays the minimum, maximum and the average value of the selected mesh quality measure in the selected region. It may be necessary to check other mesh quality metrics such as skewness, and specifically for polyhedra or polyhex core meshes, the warp factor on the faces to ensure that the generated mesh is of good quality. In our demo, the orthogonal mesh quality is 0.05. Note that we are using 4 processors for creating the mesh. There may be differences in the mesh quality and the overall cell count if the different number of processors is used. as it is recommended to maintain the quality above 0.1, we need to improve the mesh quality, which can be done with the help of an additional task in the workflow. Right-click on Generate the Volume Mesh task, select Insert New Task and click on Improve Volume Mesh. In the Improve Volume Mesh task, the basic user input required is the cell quality limit. Here, the user can specify the minimum acceptable orthogonal quality for the mesh. The default value is 0.15 and the range is between 0.01 to 0.5. Let's keep the default value for this demo. The settings under the advanced options can be left at their default values for most of the cases. For more information on each of these settings, please refer to the user guide. Click on Improve Volume Mesh button. Fluent will now regenerate the volume mesh with the objective of improving the quality. Fluent will aggressively change the volume mesh in an effort to satisfy the user entered value. It is recommended for the users to check the new volume mesh to ensure it is appropriate for their need. After the improve operation, the minimum orthogonal quality is 0.1512, which is substantially higher than the original quality and is also above the user specified value. Alternatively, the user can set the mesh quality threshold criteria within the Generate the Volume Mesh task. In the advanced options, irrespective of the volume fill method, the user can specify the quality improve limit value, which specifies the threshold below which the quality improvements are automatically invoked while generating the volume mesh. By default, the value is set to 0.05. However, the user can change this value as required. Once the user is satisfied with the mesh quality, the mesh can now be considered simulation ready and can be transferred to the Ansys Fluent Fluid Flow Solver to perform simulations. The single window user interface of Ansys Fluent was created keeping users' experience in mind while navigating the end-to-end simulation workflow. The user can simply click on Switch to Solution button located on top left corner of the ribbon to transfer the mesh to the Ansys Fluent Solver. Alternatively, the user can also invoke Switch to Solution Mode text command in the console window. Let's summarize what we learned. We understood what the volume mesh quality is and how to check it in Ansys Fluent Meshing Watertight geometry workflow. We also discussed how to improve the volume mesh using an additional task in the workflow. Finally, we touched upon the different ways to switch to the solution mode. With that, let's end this lesson.